Last time we talked about the graph of the sine and the cosine function. Let's look at what's called the sinusoidal graphs. So if I take the graph of the cosine function, so that's this pink one, how do I know right away looking at it? The sine goes through the origin, and remember the cosine went through the point 0, 1. If I take this function and I pick it up and move it pi over 2 units to the right, so notice if I pick it up and move it, I'm actually on the sine function. So this is actually kind of a cool deal that the sine and cosine functions definitely have something in common. They're just simply a shift, okay, in this case a horizontal shift to the right, pi over 2 units, and then you get the same function. If I'm looking at what we call the amplitude, so my max value and my min value, my normal cosine function, remember, was the max was 1, the min was -1. Well, if I put a 2 out front here, then notice what changed, my max and min, right? Nothing else changed. I'm still hitting 0 at pi over 2. Still hitting 0 at 3 pi over 2, but what changed was that it did a vertical stretch based off of that number, and that number in front of the function is called the amplitude. So when I have some value, notice if I don't have a value, you could say, well, you do, you have 1, that's where you get the 1 and -1, then I can say the amplitude stays between the negative of whatever my amplitude value is and the positive of it. The period of a sinusoidal function, if you remember the cosine, the period was 2 pi because by the time I get back to 2 pi, I'm back at the same y value where I started. If I replace and put 3x in here, we talked about this the last lecture, this is a horizontal compression by a factor of 1/3. Notice what happened is basically I'm dividing everything by 3, okay? My x values, pi becomes pi over 3, 2 pi becomes 2 pi over 3. So in other words, this is moving faster, right? Because before I'm even at pi, I've already went through one period. So this value inside here tells you, gives you information on your period, and how you find this. I know t, I don't get it either, but how you actually find it is by 2 pi divided by omega, where omega is this value inside your function, okay? So this coefficient on your variable. So as you can see, the period of this one would be 2 pi over 3. And I go up here and I see certainly by the time I go through back to where I started, I'm at 2 pi over 3. All right, to be able to graph these, it's kind of nice to know these key points. And these were listed when we talked about the properties. But again, looking at the left one and the right one, right away, sine starts at the origin, cosine starts at 0, 1. But these are nice key points for plotting because it helps you see. Remember when we were doing the vertical stretch, we still had the same 0 values. So these are very good points to know, and we use these for graphing sinusoidal functions using these key points. So what we do is we figure out what the amplitude and the period is. We divide the interval into 4 subintervals. So in other words, if we have one period, we're chopping it into 4, so we're dividing by 4. Then we use the endpoints of the subintervals to get us our 5 key points on the graph, and we plot those and we connect the dots. So here I have this function y equals 3 times sine of 4x. What's the amplitude? Can't hear you. You're yelling, right? It's 3. It's that number right there. What's the period? Remember, you find the period based off of omega, which is the number in front of the x. So it's 2 pi over that number, that value, and reduced it to become pi over 2. My subinterval length, so going through a full period, I'm at pi over 2. I want to chop this into 4s, so I divide by 4. So this is saying each subinterval will be pi over 8 long. So how do I set up my subintervals? I always start at 0. If the subinterval length is pi over 8, then the first one's easy because it's 0 to pi over 8. I start my next subinterval at pi over 8, and then I add another pi over 8. So that'd be 2 pi over 8 or pi over 4. I'd start my next interval at pi over 4, and I actually went back to 2 pi over 8 because it's easier for my brain to add. And I add another pi over 8, so I get 3 pi over 8. And then finally the last one, which is actually kind of funny, you don't even have to say, well, it's 3 pi over 8 plus 5 plus pi over 8, which is 4 pi over 8, which is reduced to pi over 2. You better end at the end of the period. Okay, so you start at 0 and then you end wherever the end of the period is. And that's what's nice about these. So now I can get my key points here. So my key points are based, this is my sine. I'm always going to start at 0, 0, okay, unless I'm shifting something, and I'm not in this case. And then I look at, if you notice here what I'm doing is I look at the end of the subintervals. So pi over 8's there, pi over 4, 3 pi over 8, and then the end. And then the y values are based on my amplitude. So my amplitude 0, 1, 0, -1, 0, well in this case was being multiplied by 3. So that's how I'm getting starting 0, 3, 0, -3, and 0. And so I can go in a graphing program or just plot those points and I have my graph. So that's a way to graph. You could also, if you didn't want to go through all that, you could use transformations. You could graph sine of x. Then you could change the amplitude. So where you're hitting 1 goes up to 3. Where you're hitting -1 comes down to -3. And then by changing the period, once again, meaning that it's going faster. A lot of times you will see graphs like these and they will ask you to come up with an equation. I mean, why do you want to do that, right? Well, you could do some prediction for maybe something out here later. So if I want to find an equation for this graph, the first thing I have to do is figure out, does this look like a sine or a cosine? Now, you could argue and say it could be either one of them, right? Because you could have shifts. But my eyeball says, well, it doesn't go through the origin. So right away, I think cosine. The next thing, what's the amplitude? Well, 3, -3. So my amplitude's the absolute value, so it would be 3. Next, I see what the period is. So I start right here at 0, 3. And when do I get back to 3? It looks like at 1. So if the period equals 1, I set that 2 pi over omega equals 1. I solve this for omega, so the omega comes up here, and this gives me 2 pi. So this is going to be the value, the coefficient on my variable, which you see here. So this looks like the function 3 times cosine 2 pi of x. And that again is what a lot of times you use these with the graphs, is try to figure out a function so then you can plug values into the function and actually do something with this. And pat yourself on the back, another section done.